I already know. Hold on. I'll give you already one.
Alright, 44 from the practice test we just took. A square is inscribed in a circle. The area of the circle is pi. What is the area of the square? So for the explanation, down here, the area of a circle is pi r squared. So since the area of our circle is given as pi, radius equals 1 for our circle.
Oh, boy.
You see what happened now?
I guess. So all the way across we two, you make that into four quadrants of square.
Yeah, from the original problem, the area of the circle is pi. So if the area of the circle is pi, and you cut it into 4 different things like this, then you end up with a radius of r. So pi r squared would give you the area of pi. So this is the formula for area of the circle, and the area is pi is what is given to you. So the only thing you can multiply pi by to get pi is 1. So r squared would have to be 1, which makes r 1. So if you go from there, if r is 1 and this is 1, the rest of the explanation, the area of a square is given by a equals s squared from the diagram, and a Pythagorean theorem you can use to figure out what the hypotenuse of this triangle is here. So here's a right triangle, and the hypotenuse of it happens to be the side of a square. So you would do s squared equals r squared plus r squared equals 2r squared. So thus you would have to end up with 2 for that one. So if that's 2, then what's the area of the entire circle? Okay, well, if you do what they're saying to do, my marker is probably a little bit too big.
How would you get 2? Or how would you get equals 2r squared?
Oh, well, you'd come up with this. We can possibly do it a different way. R squared plus r squared equals the hypotenuse. We'll just call the hypotenuse x squared. So if I have 1 squared plus 1 squared,
That equals 2 squared.
that would be 2. That would just be 2 equals x squared, and then you would end up with x being equal to the square root of 2. Alright,
No,
so
I'm still confused. I don't get where you're getting 2r squared.
well 2r squared is what they put. We don't have to use everything that they put, but for their Pythagorean theorem, they're calling what I said was x. Like when I'm solving for that, they're calling that s. So they've done s squared equals r squared plus r squared. All they did was add r squared and r squared to get 2r squared.
I got that.
Okay.
So what's the answer?
Well, we're not finished yet, because we found square root of 2 to be one side. So there's a square root of 2, and what is the problem asking for? What is the area of the square? So if one side is square root of 2, what do you do to one side of a square to get the area of it? Not by 2.
4.
No.
You said square. That's 1 quadrant, right?
Yeah, to find the area of a square, you square one side. And the side that we found was a square root of 2. So square root of 2 squared would be 2. And that turns out to be choice J. Alright, so 45, circles A, B, and C are tangent to one another. That means they just barely touch. Find the radius of circle A. So circle A is up here. If AB is 7, so that's this distance here, is 7. AC is 5. That's this one right here, it's cut off. And BC is 9. Alright, so what have they done here? You have to get 3 equations. You have to solve by substitution on this one. They're doing it by substitution. So you have to get these three equations and then solve them as a system of equations. So if we look back up here, they had a plus c is 5. So you do it this way. A, the small a, is referring to this side here. That's small a. And then small c is referring to right in here. These little tiny sides there. And then small b is just this radius there. So that's radius c, radius a, and then radius b. So can you see how they would do a, the radius of a, radius of b, add those two together to get 7? Because this whole side here is 7. And there's the radius, and there's a radius for the other circle. A plus b would have to be 7. Do you see where that came from? Alright, so over here, c plus b would be 9, and then a plus c would be 5. So down here they solved that system of equations, and there's all different kinds of ways you can do that.
How did you find that out?
How do we find those equations out from this?
Yes.
Okay. Well, this
Wait, is
diet.
it the same thing as the thing on the board where you set something equal to that? Say I have x squared, or not x squared, x plus 7y equals 32. 4x plus 8y equals 40. And then I take the top and times it by.
Yeah.
4. Okay.
Yeah, it's similar to that. So, but you need to understand where these came from, like the actual equations. This diagram is given to us. We haven't filled anything in. This is everything they put, and this is a 5 here. But the way it is with these triangles, the radius here and this radius here form one whole side of this triangle. And this this is B here. You know that since this radius is A, this must also be A as well, because it's a radius inside the same circle. So even if I put something out there, it'd be A. So that's why we have A plus B to be equal to 7. So we'll put that down. And then down here, here's radius C and B. If we do B plus C, we get 9, because that's the side of that triangle. And then A plus C will be equal to this 5. And then we have to solve it as a system of equations. So what they've done down here is they've solved for in equation 2 here in this one, A equals 7 minus B. They've solved for A, and they've substituted A equals 7 minus B into equation 1. So instead of A, they're putting 7 minus B in there. They're trying to get these all to work out.
Okay, I see that. So you could, so instead of A on the first problem would be 7 minus B plus C equals 5.
Right.
And then you could, I lost it actually.
Okay, well we can finish it out from there. So equation 2, and I can just do it off to the side, zoom out a little bit. So in equation 2, they have A plus B equals 7. And they've solved for A. So 7 minus B. And they're plugging it into equation 1 here, because it already has a C in it and an A. So instead of putting A plus C equals 5, they're going to put 7 minus B plus C equals 5. And the reason for that is because if you end up with a B and a C here, you have another equation with a B and a C in it. So that would be B plus C equals 9. But you have to simplify this one, so if you just skip down here a little bit, you would have negative B plus C equals 5 minus 7.
So it'd be negative B plus C equals negative 2.
Negative B plus C equals negative 2.
B plus C equals 9.
Yeah, we'll put that right. We'll just draw a line there, and we'll put that with B plus C equals 9.
And so you can take the bottom positive by negative. Yeah, it's probably right now. It's probably right now. So the B's cancel out, so it would be 2C equals negative what?
Yeah, 2C equals, now you're adding together.
7.
So it'd be 7. So C would be
7 over 2.
7 over 2.
Plug C back in to B, so into B plus C equals 9, so it would be,
Right,
so you take 9 minus 7 over 2.
right. 9 minus 7 over 2. And 7 over 2 is 3.5.
So it would be 5.5. Yeah, 5.5.
Yeah. 9 minus 3.5 would be
5.5.
5.5.
Yeah.
So we end up with this.
So you plug that into the equation at the top.
What we got to keep track of this here. This was B. So now we got to find A. And A was A plus B equals 7.
So A plus 5.5 equals 7. So you take minus 7 minus 5.5 and equal 1.5.
Right, so A is 1.5. Now what's the question even asking after we've done all this stuff? Find the radius of circle A if AB is 7. So circle A in here,
So there would be 1.5.
yeah, the radius is A. So we found A to be 1.5. So which answer would it be?
3 over 2.
Yep, 3 over 2. ABCD is a parallelogram. AE is 7x minus 1. So we'll dump that in there. And EC is 5x plus 5.
You have to add these together.
Well,
I
let's
feel
see.
so stupid. You do.
We have to find AC.
Oh, I'm gonna kill myself. I know how to do this.
Well, I probably shouldn't put that on video. Well, anyway, this is AB and this is C. It's cut off, and
So
D.
7x plus 5x equals 12x. 5 plus negative 1 equals 4.
So you'd have 2x equals 6. X would be 3. And if you find AC, you simply have to go back and do this to get 21 minus 1 is 20. And then for this one, 15 plus 5 is 20. Add them together and get 40. In the accompanying figure of a circle centered about point 0 or point O, the measure of arc AB is pi over 5 radians. So we'll put that in there. Pi over 5. Find angle OBA. Now it's this one with it's already been marked off. Yeah, so we got to find that one. All right, for the solution on this. Now this goes back to a theorem. So you have to know central angles and triangle basics.
This is why.
So from a theorem, you know that a central angle forms a measurement to the arc it intercepts. So the measurement is given as measure angle AB is 1/5 pi radians. So back up here.
I think I'm just going to accept the fact that I'm not going to get anything higher than 0.2 on my ACT.
Well, you don't have to necessarily accept that. We haven't finished the problem yet.
Well, no, I have no idea. This is not going to sink in, dude.
Well, no, I mean, look at this. See this? You know that this arc, which is this right here,
Yeah.
is pi over 5. It's the same thing as your central angle in here. So that's pi over 5. Now, whenever you have a triangle created from a central angle, and then the other end of this out here is a chord, which is not going to be touching the center, that means that this angle and this angle are going to be the same.
It's an isosceles?
Isosceles triangle. Therefore, notice that all these measurements here are in degrees. So you're going to have to convert pi over 5 into degrees. Now, if you convert degrees into radians, you have to multiply by pi over 180. But if you convert radians into degrees, you have to multiply by 180 over pi, so that the pi's cancel out. Huh?
What's a radian?
Radians, just another way of measuring angles. Remember back in Algebra 3, we did radians in there where you had to multiply by pi over 180 and then 180 over pi to go back and forth. It was on polar coordinates. The circular graph.
Might have been before I got here.
Well, remember this. This is a radian form of a degree measurement, of an angle measurement, I should say. And to get out of it and back to degrees, you have to multiply by pi, or multiply by 180 over pi. Now that's even if it's a decimal that they give you. You still multiply by 180 over pi. So these cancel.
So that's definitely not the answer.
Right, we're not done yet. 180 over 5 is 36.
I thought you cross multiply.
Cross cancel. It's not a proportion. It's just a multiplication problem.
That's gonna confuse me. So why is there a dot in the middle?
Dot in the middle. Oh, this is multiplication.
Well then what? You cross multiplying.
No, you only cross multiply when you have a proportion that has an equal sign in the middle to cross multiply to solve. But when you have two fractions multiplied together, you can cross cancel diagonally.
Okay, I get it now.
All right. So this.
So just ignore that dot and just think of it as a big fraction. And
Yeah.
cancel out the.
Right.
I'm good. I'm good.
So inside here, we found that this is 36 degrees. If this angle measurement is 36 degrees, and we know that this one and this one must be the same, you can set this up.
Okay, hold on. Can you take 180 minus 36, find out whatever the answer is there, and then
Divide by,
2.
yes, 180 minus 36, divide by 2 will give you the measure of angle B.
Okay. Why? I know how to do these, I just don't know how to set them up.
So what should it be?
72.
72, let's see, and that was choice J.